In this video, we are going to explain the difference between instantaneous and average velocity, and how to calculate the two. First, let's go over velocity in general. Velocity is the speed of something in a specific direction. In physics, it is not to be confused with solely a speed, because velocity measures direction in addition to rate. For example, a velocity looks something like this. The plane flew 400 miles per hour, a speed, going northwest, a direction. Now let's talk about instantaneous and average velocity using a fun example. Let's say there's a runner. We can call him Captain Groovy for now. Groovy is super excited for the 30th annual 80s Fun Run and has been preparing for weeks. We are going to model his glorious run on the graph so we can figure out his instantaneous and average velocities. The race starts at the beginning of Elm Street at position 0. The starting pistol is fired, and Captain Groovy takes off, pumping with adrenaline. He runs at a constant speed for 100 meters and covers it in 30 seconds, now at position 100. Let's try to find the instantaneous velocity at certain moments in his run. Instantaneous velocity is exactly as it sounds, the velocity in 1 instant. If he's going at a constant speed at all instances, in the duration of the race, his instantaneous velocity is the same throughout. Let's take a look at a position time graph for Groovy. His position increases 100 meters in 30 seconds. On this graph, Groovy's velocity is equal to the slope because the graph measures his change in position and time, which is velocity. Because he moves at a constant velocity, the graph is linear. All points along the graph have the same slope, so its instantaneous velocities at those points are all the same. 100 meters divided by 30 seconds is about 3 1/3 meters per second. The average velocity over those 100 meters will be the exact same as the instantaneous velocity, because the average velocity is the overall change in position divided by the overall change in time, which is the slope of the entire line. This is the same as the slope at any point, so at a constant velocity, average velocity equals instantaneous velocity. But what if Groovy is not going at a constant speed? Instantaneous velocity is not simply the slope of the position or time graph, because that slope is always changing. Let's say he is accelerating constantly over the first 100 meters and gets there in 25 seconds. How would we find his instantaneous velocity at 20 seconds? Well, you can simply use the equations of motion. We know this equation, that change in x equals instantaneous velocity plus 1/2 acceleration times time squared. And we know the change in position, the initial velocity and the time, so we can solve for the acceleration. First, insert the variables into the equation. 50 meters equals 0 meters per second multiplied by 20 seconds plus 1/2 acceleration times 20 seconds squared. And then the first part is canceled because anything multiplied by 0 is 0. So we are left with 1/2 acceleration multiplied by 400 seconds squared. Then you multiply both sides by 2. So 100 meters equals 400 seconds squared multiplied by a. And finally, you divide both sides by 400 seconds squared to isolate a. This turns out to be about 1/4 meters per second. We also know the equation, final velocity equals initial velocity plus acceleration times time. This gives us a final velocity if we know the acceleration over a certain period of time. So we can find Groovy's instantaneous velocity at 20 seconds by multiplying 1/4 meters per second, the acceleration, by the time, 20 seconds. And it turns out to be about 5 meters per second. The answers are different here because the first equation solved for acceleration and the second solved for velocity. We can also approximate the velocity by drawing a tangent line at a point on the curve. We can draw in this tangent line and find the slope of that tangent line to approximate his velocity at that point. This will turn out to be, you all know the equation for slope, about 5 meters per second, just like the equation got us. The tangent line is more helpful when you have a graph like this, without a constant acceleration. Average velocity is a bit simpler. All you have to do is take the total displacement over the total time. So even though Groovy's speed changes constantly over the first 100 meters, he still ends up going 100 meters in 25 seconds. So he averages 4 meters per second, regardless of all of his instantaneous velocities along the way. All in all, instantaneous velocity is the velocity in one instant, and if velocity is constant the whole way, the instantaneous velocity at any point will be the same. But if the velocity is not constant, and there is a constant acceleration, you can use two equations to find the instantaneous velocity at any point, or you can use a tangent line on a position/time graph. Average velocity is total displacement over total time.